Solar energy received at any point on the Earth varies according to the angle of the sun in the sky. At the December solstice, the subsolar point falls on the Tropic of Capricorn, and thus the sun is directly overhead there at noon. Away from the subsolar point, the noon sun appears nearer to the horizon. Through the course of the year, the subsolar point moves between the two tropics. At equinox, the noon sun is directly overhead at the equator. At the poles, the rays are horizontal to the observer and the sun appears to be on the horizon. At the June solstice, the subsolar point lies on the Tropic of Cancer. Oblique rays illuminate the Arctic Circle region. Solar intensity depends on the angle of the sun, which changes through the day and seasons. Solar radiation received also depends on duration. While the Earth makes one rotation in 24 hours, daylight length varies with latitude according to how the tilted Earth intersects the circle of illumination. We will observe the diurnal cycle at 3 points while the season changes. At the right are two views of the Earth, shown from above and from the side. At the left is a 24-hour clock, showing daylight and night periods at the 3 points. Let's watch the Earth complete a rotation beginning at 6 p.m. on December 22nd. Point C remains in darkness. Point B experiences a shortened daylight period. Point A on the equator has equal daylight and night periods. Now watch a rotation on February 6th, about halfway to the equinox. Point C has a short daylight period. Point B's daylight period is a little longer. Point A still has equal daylight and night periods. On March 21st, the circle of illumination passes through the poles. Daylight and night are of equal length at all 3 points. As we have now seen, both the angle of the sun in the sky and the length of the daylight period depend on the latitude and season. These two factors act together to determine the amount of the sun's energy available to heat the Earth's surface at a location.